What's up? Next objective, subtracting polynomials. Nice thing about subtracting polynomials is you can just do one thing, treat them like addition. Biggest mistake I see kids make is they think, I can just do the subtraction, I'll be fine, I know how to subtract. And that is true, and you can. I don't want to lie to you, you can. But I've seen a lot of kids forget about that subtraction, especially as the polynomials grow. So I'm going to show you what I highly recommend. We have 5x minus 7 subtracting the quantity of 2x plus 1. The important part there is that we were subtracting that quantity. So that means that 2x plus 1, that entire thing is being subtracted. So all of that has to be taken into account when you're subtracting. Here's my suggestion. The first thing I'm going to do is I'm going to change that subtraction to addition. And we know we can do that through our definition of subtraction. Our definition of subtraction says that you may change subtraction to addition as long as you add the opposite. So what we're going to do is we're going to take that subtraction, we're going to make that addition, and we're going to add the opposite. Now, the problem with that is you're doing the opposite of a quantity. So how do I do that? Well, I take advantage of the fact that I can write all of these quantities all I want. And I could put ones in front of them and distribute. So I'm going to do the same thing here. I'm going to put a 1 in there and I'm going to distribute. But since it had subtraction in front of it and I did addition and added the opposite, that is a -1 that I'm going to distribute. So I'm going to distribute that -1 in, and then I'm going to proceed exactly like addition. So this guy did not change. I mean, I can distribute that 1 all day. It's still going to be 5x minus 7. Over here, however, when I distribute the -1, that becomes -2x plus a -1 or -1, however you prefer viewing that. Adding a negative and subtracting, as we just said with the definition of subtraction, same thing. So if you prefer subtraction here, do it. If you like the plus and -1, do it. Never really mattered to me. So now I'm going to identify my like terms because it's now addition. I just changed my subtraction to addition. I'm going to identify my like terms, and I'm going to go ahead and combine them up, which simply means I'm going to add them together. 5x and -2x, of course, is 3x, and your -7 plus -1 becomes -8 or -8. Easy peasy when you do that distributive of the -1. Step it up a notch. I think you should find that fairly simple. We'll step it up here. Let's do some quadratic trinomials. Exciting, huh? So let's do 3a squared minus a plus 1, and we're going to subtract from that 2a squared minus a plus 7. Okay, so now, no big deal, just more terms. It's just your process is the same, you're just applying it to more things. So the first thing I'm going to do is I'm going to take a look at this and I'm going to go, okay, it's subtraction. Subtraction gets a little bit scary, a little difficult. I'm going to turn it into addition. Beautiful part about math. I'm going to make this plus a negative, knowing that that means I'll be distributing a -1 into that set of parentheses or grouping. So now I'm going to bring everything down. My 3a squared minus a plus 1 did not change. Now I'm going to add on what occurs after I distribute the -1. -1 times 2a squared is -2a squared. -1 times this minus a, or opposite of a, becomes plus a, or positive 1a. And the -1 times the positive 7 becomes -7. Hopefully that's pretty easy. Now we're going to identify our like terms, and we're going to combine them. I'm going to start moving away from all the circles and all that stuff. We've practiced this for a while now. So I'm going to find my like terms, my 3a squared, my -2a squared. That, of course, is 1a squared, or just a squared. You usually don't put a coefficient of 1 in front. If you do, that's fine. I don't mind. Then I have this opposite of a and this positive a here. Of course, that's -1a and positive 1a. When I combine them, guess what? Gone. 0. They disappear. So they're gone. Then I have a positive 1 plus a -7. That gives me a -6. And I'm left with this quadratic binomial of a squared minus 6. One more. If you're feeling good about this when I put this up, go ahead and pause the video and give it a shot. Let's take 3y cubed plus 2y minus 7, and let's subtract from that 2y cubed plus y squared plus 1. If you're feeling confident, pause the video, give it a try. Check your answers when you're done, or simply follow along and let's do it together. First thing, I'm subtracting two polynomials. I don't like dealing with subtraction. Things get lost, things get difficult. I'm going to make that plus the opposite. Of course, that means that I'm going to have a negative 1 there, and I am going to distribute that. Now I'm going to go ahead and perform that distribution. I've got 3y cubed plus 2y minus 7 out front. Distributing that negative 1 is going to turn that into negative 2y cubed, negative or minus y squared, and of course, negative 1. Again, you can treat those as minus, or you can have those as plus a negative. Doesn't matter, whatever suits you better. So, identifying my like terms and making sure I follow in descending degrees so it winds up in standard form. 3y cubed plus negative 2y cubed, well, that's going to give me just 1y cubed or y cubed. When I then work down to my square, I have this guy here, but there's nothing to combine him with. So I just bring him down and he comes along. Then I'm going to have my y, or just my linear term here, this 2y, there's nothing for him to combine with. So he will just come down as positive 2y. Last but not least, I have my constants to combine. Negative 7, negative 1. They combine up to give me negative 8. And my final result is this cubic with 4 terms. Hopefully you find that pretty easy. It is simply turning subtraction into addition and following our addition of polynomials situation. See you.